Hello everyone. Welcome to Aviation Engineering YouTube channel. Today also I took a new lesson. This is regarding AT chapter 2071 power plant. So last time I uploaded the second video. So this is the third video. So this is regarding the modular design. So if you still not watch the Aviation Engineering YouTube channel videos, please watch. And also, if you still not subscribe to Aviation Engineering YouTube channel, please subscribe and please share these videos with your friends, relatives who like to learn about aircraft maintenance. All right, so so now we will go to the lesson. All right, so today I'm going to talk about AT chapter 71 power plant IAE V2500-A5 engine. All right, so I'm going to talk about the modular design. Okay. All right, so this will be important for someone who want to learn about V2500 engine. So this is very basic. All right, okay, so let's go. Yeah, so this is V2500 IAE V2500-A5 engine. So I took from the internet. All right, so this lesson explains the engine's modular design, and which means the engine is made up of separate parts. Okay, you can see this engine is made up of, like, see, you can see the fan here, the compressor sections, combustion section, right, turbine section, like this, different parts. Okay, so which means the engine is made up of separate parts or section that can be easily removed or replaced. So this one, these parts we can easily remove and replace. All right, so it is also shows where the aerodynamic stations are located. Right, in this lesson, I mean later parts, you can know what are the aerodynamic stations. These are specific points on the engine used to measure airflow and performance. So finally, it is identifies where the Borescope ports are. Right? Borescope ports, why we use Borescope? We use Borescope to check what happened inside the engine, like cracks inside the like compressor fans blades. We can, if there's a crack, we cannot see from the naked eye, so we have to use the Borescope, right? So it identifies where the Borescope ports are, which are small openings that allow technicians to inspect the inside of the engine without taking it apart. All right. So now the lesson content is number one, modular design. I'm talking about modular design, and then the low pressure rotor, high pressure rotor, combustion chamber, accessory drive, accessory locations, and aerodynamic stations and stage numbering, and Borescope ports. All right. Okay, so let's go to the first one, modular design. Okay, you can see the real picture here, the engine. Okay, you can see this is the fan. Okay, this from this area we called as case. All right, and this is the accessory drives. Okay, and this one is high pressure system. Here all called high pressure system, and here's the turbine section, low pressure turbine. So this is called the modular conception. Okay, all right, so this is, you can see this is intermediate case, right? So this is the fan. Blue color you can see is fan, and yellow color is intermediate case. The green color is accessory drive, red color is high pressure system, and the amber color is low pressure turbine. All right, okay, so the IAE V2500-A5 engine is built with 5 main models. All right, so the 5 main models, what are the 5 main models? The fan, the compressor, combustor, turbine, and exhaust modules. All right, 5 main modules. Each of these modules plays a critical role in the engine operation. Right, so the fan module draws it large volume of air, providing the majority of the engine thrust. It means the fan module. Okay, you can see the fan module. This module, what they are doing is draws in large volume of air into the engine, because it will provide a majority of the engine thrust. And then the compressor module. Okay, compressor module increase the pressure of the portion of its air. It means the compressor module, step by step they increase the pressure. Preparing it for the combustion. In the combustor module, you can see here is the combustor module. The compressor air mixed with the fuel. In combustor module, compressed air mixed with the fuel and ignites, create a high energy stream. So the turbine module, here the turbine module extracts energy from this steam to drive the compressor and the fan. So while the exhaust module control the release of the remaining airflow, managing emissions and noise. Okay, exhaust module, they manage the emission and the noise also. So this module design allows each sections to be independently maintained. So repaired and replaced, it means like that. Because of this modular design, we can we don't need to repair or replace or maintain all the engines, so we can replace or repair by modular wise. So without needing to dismantle the entire engine. Example, if you want to if they have something problem with the fan, so we can just only take out the fan and means can install the new one like this. So this makes the maintenance process more efficient, reduce downtime, and ensures reduce downtime and ensures the engine can be quickly returned to service with minimum disruption. All right. Yeah, where you can see the five primary modules are what? Fan, intermediate case, high pressure system, including high pressure compressor, combustion chamber, and the high pressure turbine. And next, the low pressure turbine, and last accessory drive. All right. Okay, now we'll go to the next one. Is the second one, low pressure rotor. Here you can see the low pressure rotor is like this. Here the fan module, fan is there, and the booster here, and this is the turbine. This is called low pressure rotor. All right. Yeah, you can see the bearings. Okay, one bearing, two bearing, and this is the fifth bearing. Okay, 5 bearing. Yeah. Okay, so the low pressure rotor, also known as the N1 rotor. In this engine, the low pressure rotor we named as N1 rotor is a crucial component of the engine, supported by 3 bearings for stability. Okay, so low pressure rotor is supported by 3 bearings for their stability. It includes 2 main parts, fan and 4-stage compressor. This low pressure rotor includes 2 main parts. What are they? Fan and the 4-stage compressor. The fan is responsible for drawing the large amount of air, providing significant thrust. The 4-stage compressor then increases the pressure of this air before it enters the engine core. This rotor is driven by 5-stage turbine, which extracts energy from high energy exhaust gas to power both the fan and the compressor. This setup ensures efficient airflow and power generations, contributing to the overall performance of the engine. Okay, you can see where's the bearing, 3 bearing, right? 1, 2, and 3. Here is the bearing, and you can see the bearing 1B. Here is the 1B bearing, that is called thrust ball bearing. Okay, we can call it as thrust ball bearing. The second one, bearing 2R, is called roller bearing, and this one also BR 5R means also roller bearing. So these 2 are roller bearings, and this one is thrust ball bearing. Okay, just remember. Okay, normally we can call it as fan and then the booster section, and this is the low pressure rotor, like fan and the booster section and the turbine section. Okay, compressor is driven by the turbine. All right. So next, go to the high pressure rotor. High pressure rotor, here you can see the high pressure compressor over there and high pressure turbine. Okay, high pressure turbine. So here is the low pressure turbine, here is the high pressure turbine. So you can see the high pressure compressor section and high pressure turbine. So the high pressure rotor known as N2. Remember the low pressure rotor, what we called as N1, and high pressure rotor we known as N2. Rotor is supported by 2 bearings. Okay, low pressure rotor supported by 3 bearings, high pressure rotor supported by 2 bearings. It includes 10-stage compressor and powered by 2-stage turbine. Okay, it includes 10-stage compressor. In high pressure compressor, they have 10 stage of compression, right? And 2 stage of turbine. In turbine, they have only 2 stages, but the compressor section, they have 10 stages. We see the low pressure, you can see low pressure one, this one have a fan and 4-stage compressor. In booster section, you can see 4-stage compressor and 4 stages of compressor, and the fan and the turbine have 5 stages, right? But in the compressor section, 10 stage of compressors, 10 stages of compressors are there, and 2 stages of turbine. Okay, just remember, the compressor increases the pressure of the air is multiple steps, like 1, 2, when you comes to 1, 2, 3, 4, 5, 6, like this, the pressure will be increases. Okay, increases, and the pressure of the air in multiple steps, making it highly compressed before it enters the combustion chamber. When the air is come through like this, go through like this, and the compress, and the pressure is increases, and then release for the combustion section. Okay, the students then extract energy for the hot gases produced during the two-stage turbine, okay, combustion chamber, and the two-stage turbine, then extract energy. Okay, then extract energy, the energy from the hot gases produced during the combustion to drive the compressor. Okay, the purpose of the turbine is drive the compressor. This rotor is crucial for generating high pressure needed for the efficient engine operation, and its design allows for smooth and stable performance. Okay, so let's see the bearings. They have two bearings, right? 3B and 4R. So 3B means thrust ball. This is thrust ball bearing also, and this is roller bearing. Okay, remember, for the low pressure rotor, right? Low pressure rotor, they have 3 bearings. The first one is the thrust ball bearing, and other 2 are roller bearings. And in the high pressure rotor, they have 2 bearings. The first one is ball bearing, and the second one is roller bearing. Just keep it, remember. Okay, now let's go to the combustion chamber. Combustion chamber is here. Okay, combustion chamber inside here. So we can see this is the combustion chamber. So we will talk about the combustion chamber and how is the process inside. So I will talk in the module 15. In this lesson, I will discuss about it in detail. All right. So just wait for this video. All right. So the combustion chamber is situated between the high pressure compressor and the high pressure turbine. Right. Remember, the combustion chamber is located in between high pressure compressor and the high pressure turbine in the engine. So after the air is compressed by the high pressure compressor, it means if the ice comes like this and then compress, air is compressed, after compressed by the compressor section, high pressure compressor, it flows into the combustion chamber. Here the compressed air is mixed with the fuel and ignite. Inside the combustion chamber, the high pressure air is mixed with fuel and ignite. This process creates a high energy flow of hot gases. These gases move to the high pressure turbine, which extracts the energy from them to drive the compressor. Then after that, the high energy will evacuate. After that is this turbine will rotate and energy release, and because of turbine rotates, the compressor will rotate. Okay, turbine which extracts energy from them to drive the compressor. This setup is crucial for generating the power needed for the engine to function efficiently. So it is of the annular type and integrates the N4 bearing support. So it has ports for 20 fuel nozzles and 2 igniter plugs. Remember, inside the combustion chamber, there has 20 fuel nozzles and 2 igniter plugs. Okay, just remember. Okay, next go to the accessory drive. Okay, you can see here is the accessory drive. Here is the angle gearbox, right? Here is the accessory drive is connected to the fan in the case. Okay, fan case. Right, you can see the rear picture. Here is the accessory drive or gearbox. Everything is there, right? Okay, so the accessory drive, also known as the external gearbox, is attached to the lower part of the fan casing. Its job is to provide mechanical power to various accessories of the engine. It means accessory gearbox. What is the purpose of accessory gearbox? Is to provide mechanical power to various accessories of the engine. So gearbox converts the engine rotational energy, right? Gearbox, they converts engine's rotational energy into power needed to run accessories such as hydraulic pumps, generators, it means electrical generators, hydraulic pumps, and other systems. By being mounted on the fan casing, it ensures that these essential components receive the power they needed to operate effectively, supporting the overall functionality of the engine. All right, so it is composed of the angle gearbox. Okay, you can see the main gearbox, and here is the angle gearbox. Accessory gearbox also has an angle gearbox, right? It is composed of angle gearbox to the main gearbox. The main gearbox is driven by the high pressure or N2 rotor via the internal gearbox and the angle gearbox. Remember, accessory gearbox directly connected to the HP, high pressure compressor, or else high pressure rotor, or else N2 rotor. Okay, just remember it. Then let's go to the accessories location. We can see in the gearbox, right? In the gearbox, we can see what are the accessories located over there. Okay, you can see when you see from the down, here is the main gearbox over there. Okay, here is the main gearbox, and this is the angle gearbox, and from angle gearbox is directly connected to the high pressure rotor. So the main gearbox has mounting pads. Main gearbox has mounting pads. You can see so many mounting pads that are used to power accessories. The pads allow the gearbox to transfer mechanical energy to various components, ensuring they operate effectively. These setups helps in driving essential systems that supports engine performance. So the main gearbox consists of gear train that reduce and increase the rotational speed to meet specific drive requirements on each accessories. All right. Okay, you can see here is the angle gearbox. Okay, this is the main gearbox. Okay, from green color, and you can see this is the de-oiler, and in number 4 bearing scavenge valve. Number 4 bearing scavenge valve, and this is the starter. This is used to start the engine, and here also has the hand cranking. We are using to do when doing the Borescope inspection. We are using hand cranking to slowly rotate the high pressure compressor and high pressure turbine. Okay, and EEC permanent electrical engine electrical sorry, I don't remember this one, right? EEC permanent magnetic alternator here, and this is hydraulic pump, and this is oil pump and filter. Here you can see the oil tank, you can see from the sideway, and oil scavenge filter. You can see oil scavenge filter. You can see fuel metering unit over there, and fuel pump assembly and oil scavenge pump. Yeah, in future, in next lessons, I will show one by one. When I'm going to explain about the component explanation, I will show you each component very clearly. Right? Okay, so, and also, yeah, you can see like here is the very in detail picture, right? You can see the oil scavenge pump, fuel pump, fuel metering unit, oil tank, oil pressure pump and filter, hydraulic pump, EEC, permanent magnet alternator, and hand cranking over there, and starter, N4 bearing scavenge valve, de-oiler. Here is the IDG, the biggest component, IDG. All right. Okay, so the integrated drive generator, hydraulic pump, and starter are okay. So integrated drive generator, hydraulic pump, and starter are installed with quick attach detach system. So this system allows these components to be easily attached or removed, simplifying maintenance and repair. It makes swapping out or servicing these parts faster and more efficient. All right. So the hand cranking drive is provided on the front face. Okay, hand cranking provided on the front face. Okay, you can see here is the hand cranking. All right. So now let's go to the aerodynamic stations and stage numbering. Aerodynamic stations and stage numbering. Okay, you can see 1, 2 fan discharge area, 12.5, 2.5 booster discharge area, and number 3, 4, 4.5, and 4.9. These are the aerodynamic stations. All right, so yeah, the main aerodynamic stations on the engines are specific locations where pressure and temperature sensors are installed. Okay, the main aerodynamic stations on the engine are specific locations where pressure and temperature sensors are installed. Okay, remember, aerodynamic stations of the engines, the specific locations where the pressure and temperature sensors are located over there. So these stations are used to monitor and measure various aerodynamic parameters such as airflow and engine performance. The sensors at these stations provides critical data for evaluating the engine's efficiency and operation. All right. Okay, you can see the stations. These are the aerodynamic stations. Number 1, number 2, 12.5, 2.5, 3, 4, 4.5, 4.9. So we can see station number 1, we can see intake and engine inlet interface. Station number 2 is fan inlet. Here is the fan inlet. Station number 12.5, 12.5 over there is fan exit. And 2.5, station number 2.5 is low pressure compressor exit. Here is the low pressure compressor exit. And number 3 is high pressure compressor exit. Number 4 is combustion section exit. Number 4.5 is turbine, high pressure turbine exit. And 4.9 is low pressure turbine exit. These are the stations. Okay. Actually, in these station locations, the pressure and temperature sensors are installed. Right. Okay. Yeah. Here is the stage numbering. Now we'll go to the stage numbering. Here the stage numbering: number 1, number 1.5, 2, 2.3, 2.5, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then the turbine stages 1, 2, 3, 4, 5, 6, 7. Okay, these all are from 1 to 12 is compressor stages, and 1 to 7 is turbine stages. Okay. These are the stage number. Before I told you aerodynamic stations, and now the stage numbering. So compressor stage 1 is fan, and stages from 1.5 to 2.5 is low pressure compressor, booster or the low pressure compressor, and stage number 3 to 12 is high pressure compressor. And in the turbine section, stages from 1 to 2 high pressure turbine, and 3 to 7 is called low pressure turbine. These are the stage numbering. All right. Okay, so now let's go to the last point is called Borescope ports. Okay, yeah, they have Borescope ports. Like you can see, this is the Borescope ports. Okay, we can remove this cover and then we can use the Borescope tool to go inside and check it. Right, so the engine has several ports for Borescope inspection. These ports allow technicians to use a Borescope, a specialized tool with camera, to look inside the engine without disassembling it. By inspecting through these ports, they can check for internal wear, damage, or other issues, ensuring the engine's proper maintenance and operations. Okay, you can see, like, okay, I can tell here the third stage Borescope here, and 330. I mean, in the watch, 3.5 position. Okay, 3.5 position. 3:30 position over there, and 4 o'clock and 8 o'clock, third to fourth stage position, and 5:15 positions, fifth to sixth stage, 5 o'clock position, 7 to 8 stage over there, and 5:45 positions, 8 to 9 stage over there, and 5 o'clock positions, 9 to 10 stage over there, and 5 o'clock positions, 11 to 12 stage over there. Here combustion, 4 o'clock and 4:30 position ports over there, and 11 o'clock, 1:30, 10 o'clock, 8 o'clock, 6 o'clock, 6:30. So diffuser burner, you can see over there, and 8:30 and 4 o'clock position, second vane, right? And the third vane, we can see 8 o'clock or 4 o'clock positions. Okay, this like time is, I mentioned, like the position. Okay, right. Okay, yeah, that is the end of this lesson. Okay, thank you very much for participating in this lesson. I think you got a good knowledge about this lesson. Modules are like engine modules V2500. So CFM also same, but a bit different, and I will do it later. If you're still not subscribed to Aviation Engineering, please subscribe. Please share these videos with your friends, relatives, anyone who would like to learn about aircraft maintenance. All right, so that's all for today. Have a good day, and see you on next lesson. Bye bye.